Alright guys, so we're going to do this review a little bit differently. I'm going to try to kind of walk you through how to do the process, or like solve each problem as we go. So, if you don't have a piece of paper and a pencil or something to write with ready, I would pause and go get those things because you're going to do this work right along with my video here. And I'm going to tell you right now, I already goofed up a couple times. So hopefully there are no more mistakes. We'll see. So I'll post a question for you to try, and depending on the type of question, I'll give you a timer, maybe more time or less time depending on the problem. I'll also let you know if I feel like you could take longer or if you should take longer or less time. Anyways, once the timer's up, once all your time is done, I will go over how to solve the problem. And good luck, and let's get ready, and let's do this. Okay. Question number 1. What is the cosine of theta? And I should say, what is the cosine ratio of theta? So you have 10 seconds. Should be super easy. So the cosine ratio of theta here is cosine of theta equals 12 over 13 because cosine is adjacent over hypotenuse. And 13 is definitely the hypotenuse. No mistakes yet. Deep breath. Alright. Next. Solve for theta. So, unlike the last one, we want to fully solve for theta. Here we go. This one might take a little longer. Probably not 60 seconds, but there you have it. Okay, probably didn't take you that long, but maybe you had to find a button or two on your calculator. So if we're going to solve for theta here, the most straightforward way to do it is to write the sine. Nope, tangent. Hope I did that. I did not. Oh my god. Well, we're going to do this together for real because I have my calculator. It wouldn't be a Missouri thing if I didn't have a mistake, so there you go. We actually need to do tangent because that is not the hypotenuse and I'm just dumb. But that's fine. So we do tangent of theta equals 4 over 13. So it's the same fraction, it just needs to be tangent. And then to solve for theta, we need to take the tangent inverse on both sides. And so then you get theta alone, but we want the tangent of that, which is not going to be what shows up here. So let me just do this on my calculator real quick. So that should be 17 degrees. Oh, maybe I did do it and I just wrote down the wrong thing. I think I just wrote down the wrong thing. So 17 degrees, 18 degrees, if you're right around there, then you have it. So good job, me, kind of. Not really. Oh my god, I'm so sorry. Let's go to the next problem. Let's forget this happened. Okay, next problem. We're going to solve for x, which is the side length of this right triangle over there. So 1, 2, 3, go. Alrighty, so probably didn't take you that long, but to solve for x, we need to set up a trig function because I cannot do the Pythagorean theorem here. So I set up the trig function, I hope sine this time. Okay, good. So sine of 57, and that's because I know the opposite side is 10.8, and I'm looking to try to find that hypotenuse side, and so the one that uses opposite hypotenuse is sine, or you can use its reciprocal function, cosecant, if you're feeling frisky. And so whenever x is in your denominator like that, you can always do a little swap-a-roo, where x comes up, sine goes down. And so on your calculator, you're needing to type in 10.8 divided by sine of 57. Now you need to make sure that you're in the right mode, and as long as you are, you should get that side length is 12.9-ish, which makes sense because it should be longer than the 10 because it's the hypotenuse. So hopefully that's about what you got. Here we go for another. So moving on a little bit, we want to find the tangent of theta, and I do want to specify because I put a little bit of a different one on here, where theta is near the origin when I drop that perpendicular down. So 60 seconds is probably a little long here. You probably don't need that much time because we're just writing the tangent of theta, just the ratio. Okay, so when you drop that perpendicular down, you can label your sides as -3 and 3, making your tangent of theta -1, because opposite over adjacent right there, or y over x, which is kind of like slope. It's so cool. And -3 divided by 3 is just -1. So, okay, so on the next one, it's going to be a similar picture, but I'm going to ask a slightly different question. And it's not one we've really tried before, but I think you can get there. So, with that same sort of picture drawn, I know that theta we normally take to be next to the origin when we drop our perpendicular down, but I actually want you to answer the question, how big is theta, the degree measure of the arc shown? So how much is that full arc there that we traveled around our circle? Like if we were drawing the measure of an arc based on my initial side and terminal side, how far did that little line travel? But you can use what we did on the last one to try to help you get there. So 60 seconds on the clock. Ready, set, go. So still do it like the last one, but then you might have to do a little extra. So this one definitely will take you 60 seconds, if not more. Okay, hopefully you're able to kind of figure that one out. So I still drew the perpendicular down, and I actually did tangent again because I have x and y, so I don't have to find the hypotenuse or the radius, which is super nice. And so I can do tangent, and when I write that out, I said like kind of tangent of theta, which isn't the real theta, but that's going to equal -1 again, because -2 divided by 2. But then to find out how big that angle actually is, I did the tangent inverse of -1, which is going to be 45 degrees. So that's my little theta in parentheses. And so since 45 degrees is in that corner, and that is not how much I traveled, but that would make up the rest of the circle, I subtracted that from 360. So 315 degrees is how big that arc all the way around is. So it's kind of like how many degrees your terminal side traveled. So hopefully that can make sense. Very similar to the last one, but you just have to do a little more work to get there. Okay, so now some simple stuff, hopefully. We are going to convert to radians, so this should take you less time, hopefully. So 240 degrees, convert it to radians. Alright, so to convert to radians, we're going to take that 240 and times by pi over 180. But really I just reduced the fraction 240 over 180 and then smash it up against a pi, which reduces to 4 pi over 3. Yay. Okay, so let's try the other way. We're going to convert 2 degrees. Oh my god, I think you can see that. Oops. So convert 5 pi over 4 to degrees. 30 seconds on the clock. Gosh darn it. Mistake number 2. Way to live in the moment with me, guys. I'm so sorry. You knew what to do anyway, though. Okay, so I'm pretty sure you can see that you need to do 5 pi over 4 times 180 over pi, but really you're just reducing the fraction. The pi's divide out, the 4 goes into 180, and then you times by 5, so 225 degrees. Alrighty, so I'm pretty sure on the next few, oh no, I have one more, and then the next one should go really fast. Okay, so next we want to find a positive and negative coterminal angle with negative 19 degrees. So I know you already have one negative coterminal or negative angle, but you need to find another negative coterminal angle and then a positive coterminal angle with negative 19. 30 seconds on the clock. Alrighty, so to find coterminal angles, we just add multiples of 360 if we're in degrees, or subtract multiples of 360, or add multiples of 2 pi if you're in radians, or subtract multiples of 2 pi if you're in radians. So I added 360 to that, I subtracted 360 from that to get my coterminal angles, the positive one being 341, and the negative one being, oh my god, negative 379, gosh darn it. Mistake number 3, frickaroo. Alright, anyways, moving on. So the next few, I don't even want to show it yet because I want these to be fast. And if you feel like your unit circle skills are not fast yet, you might want to put a pause and like do some Quizlets because we want these unit circle things to be fast. So we are going to find the exact value of sine of 7 pi over 6, and it's just equal in amount using your unit circle. Bang bang, should be less than 10 seconds, but here you go, 10 seconds. Alright, we want these boys to be quick, okay, so that would be negative half. So guys, for me, in my head, I'm thinking, okay, if I'm over 6, I'm a 30-degree reference angle. So my 30-degree reference angle for sine, so my 30-degree angle, sorry, is root 3 over 2 comma half. And since I'm sine, and sine is y, I'm half. And then I'm in the fourth quadrant, so I'm negative. Sorry, long thought process there, but that's the thought process that I go through. All right, here we go again. Sine of pi over 2, 10 seconds. we get that Jeopardy music. Okay, so similarly on this one, I'm thinking, okay, pi over 2, that's a quadrantal angle, that's like 90 degrees. Sine is y. At that spot, y is 1, so 1. Bang, bang. Alrighty, here we go. Tangent of pi over 4. Alright, so tangent of pi over 4 is 1. Now the way that I think about tangents is, well, like, let me go back, I guess. So over 4 is a 45-degree reference angle. My over 4 point is root 2 over 2, comma root 2 over 2. But if I'm tangent, I always have to divide y by x, but they're the same number, and so the same number divided by itself is 1. I'm in the first quadrant. Tangent is kind of like slope, and that slope is all positive, so positive 1. Long thought process there too. But the more we do them, the better they stick in our brain. So here we go for another. What is the cosine of 3 pi over 4? 10 seconds. Alright, so cosine of 3 pi over 4 is negative root 2 over 2. Again, if I'm over 4, I'm a 45-degree reference angle. That point that is associated with your 45 degrees is always root 2 over 2 in the x and the y position. Cosine is x. Kind of doesn't matter though. But it does matter for that quadrant because I'm in the second quadrant because I'm almost 4 pi over 4, which is 1 pi. And in that quadrant, x is negative, so cosine is negative. Alright, here's another. Cosine of 210. So cosine of 210 degrees. 10 seconds on the clock. Okay, at this point for me, degrees are almost harder. So the cosine of 210 is negative root 3 over 2. But 210 is 30 away from 180, so I'm a 30-degree reference angle. And cosine is x, and so the x point for a 30-degree reference angle is root 3 over 2, and then I'm in the third quadrant, so I'm negative. Alright, cosine of 315, 10 seconds. Alright, so the cosine of 315, if ever I end in a 5, I'm always a 45 reference angle, so that's root 2 over 2, and it's positive because I'm in the fourth quadrant, and x is positive there, and cosine is x. Bang, bang, here we go. Cosine of 180, 10 seconds. Do it. Alright, so 180 is flat, your cosine, your x, your negative 1, because you're straight across. Here we go. Tangent of 315. 10 seconds. Alright, so anything that ends in a 5 is a 45 reference angle, so your root 2 over 2, comma root 2 over 2, but tangent is the division of those, which is 1. And you are negative because you are in the fourth quadrant. Also, tangent is like slope, and you have negative slope in that quadrant. Here we go. Cosine of negative 5 pi over 3, 10 seconds. So it's definitely sneaky here because it's negative, but this is half. And the negative just means I'm going in the other direction, and I'm almost all the way around the circle, and I'm a 60-degree reference angle, and I'm cosine, so I'm x, so I am half. Positive because you're in the first quadrant. Anyways, I really don't remember how many I have for you here, so if we get a blank screen, we're just done. Oh, we don't. Okay, so tangent of negative 3 pi over 2, 10 seconds. Maybe this is the last one. I think this is the last one. Okay, so tangent of negative 3 pi over 2 is undefined. And that's because 3 pi over 2 is one of those quadrantal angles. So it's on an x or y axis. it's actually on positive y because you're going in the negative direction, and since you're straight up and down and tangent is like slope, that slope is undefined, so undefined. Alright, that's it guys, and you can watch those as many times as you want, and if you want to just do the last ones because those should be fast, like that would be a fun way to review, but also Quizlet is really good, and good luck. We have an assessment later this week. Bye!